In this power analysis, we're going to have a look at an experiment that was carried out to have a look at the effect of a drug on blood pressure. The sample sizes were 7 for the control and 10 for the treatment. The difference in blood pressure was 9 millimeters of mercury, so the control was 120 and the treatment 111. And the standard deviations for the two were 10.3 and 9.8. So we need to add this data to Russ Lenths power calculator. You can see that we've got two standard deviations and they're different, so we need to unclick the equal sigmas. Click in the grey box and put in a standard deviation for your treatment, 10.3. Click in the box, put in a standard deviation for your control of 9.8. Can you see here for sample sizes it's set to equal sample sizes at the moment. Change this to independent. Again, click in the box, put in your sample size. 7 for the treatment, 10 for the control. The true difference of means was 9. I'll OK that. And our starting hypothesis was that we weren't sure what effect the drug was going to have, so we have a two-tailed test. So in this test here, where we've got a true difference of means of 9 with a standard deviation for the control and the treatment of 10.3 and 9.8, sample sizes of 7 and 10, we've got a power of 0.3867. That is, less than 40% of the time would we have expected to find this real difference that did occur. If you want to find out what sample size would be needed for a power of 0.8, you'll have to set the sample sizes to equal and then move the slider up to 0.8. So we would have needed a sample size for our treatment and control of 21. If you move to a one-tailed test, you can see that one-tailed tests are more efficient than two-tailed tests. We would only have needed a sample size of 17 for a one-tailed test. But I'll shove it back in. The final thing that we can do, I'm going to set these back to what they were before, 7 and 10. We've been solving for sample size so far. It's also possible to solve for difference of means. And that will then change this true difference of means. So we'll slide up the power here, and as we do this, you can see that the true difference of means is changing. So for a power of 0.8, with the sample sizes that we have in our experiment, we would only have been able to detect 80% of the time a true difference in means of 15.12.